All right, here we go. Hey guys, let me introduce myself really quick. My name is Rick. I've done a lot of PHP, C Sharp, Java, JavaScript, TypeScript, obviously too, in my past. And I've always been frustrated with it, like really frustrated. So this one time, I just wanted to learn what it is to have pure functions. Same input, same output. Always. Guaranteed. And then, yeah, after 300 days, let's compare it to my, almost 20 years of object-oriented programming knowledge. So, guys, be ready to relearn everything from zero, right? Welcome to Learn Your Haskell for Great Good. If you're reading this, chances are you want to learn a Haskell. True. True. Can't oppose to that. Well, you've come to the right place. But let's talk about this tutorial a bit first. I decided to write this because I wanted to solidify my own knowledge of Haskell and because I thought it could help. I could help people new to Haskell learn it from my perspective. That's cool. That's cool. I think more people should do that. Especially when you start learning something new. The way you look at things are much different from how you see it like even 1 week later, and you will never see things under that perspective ever again. So it's really good to write it down. It's also part of our journaling process. There are quite a few tutorials on Haskell floating around on the internet. When I was starting out in Haskell, I didn't learn from just one resource. I mean, I feel that. Tried to learn like Japanese ones, and there is not a single resource for this either. You have to go like through, I don't know, tons of pages, learning vocabulary, grammar, and stuff. And so I pretty much wish someone writes a book like this for Japanese too. Let's see if it works, huh, before praising it too much. The way I learned it was by reading several different tutorials and articles because each explained something in a different way than the other did. By going through several resources, I was able to put together the pieces and it all just came falling into place. So this is an attempt at adding another useful resource for learning Haskell, so you have bigger chance of finding one you like. Awesome. This tutorial is aimed at people who have experience in imperative programming languages, C, C++, Java, Python, but haven't programmed in functional language before. Haskell, ML, OCaml. I don't know ML or OCaml, just from the names. But I have done Elm and Nix a little bit in the past, so I'm not fully new into functional programming. I know the concepts and everything, but I'm quite a beginner, let's be honest. Although I bet that even if you don't have any significant programming experience, a smart person such as yourself will be able to follow along and learn Haskell. Oh, thank you. Thank you. He just called us smart. Let that sink in. What a great person. He really knows how to write a book. I failed to learn Haskell approximately 2 times before finally grasping it, because it all just seemed too weird to me, and I didn't get it. But then once it just clicked. Oh, I know that feeling, you know, when you're learning something and you don't get it. You don't get it. And then just one day, snap. That's such a great feeling. 2 times? I think I'm a 3 or 4 times now, but maybe this time is right. But then once it just clicked. And after getting over that initial hurdle, it was pretty much smooth sailing. I guess what I'm trying to say is Haskell is great if you're interested in programming. And you should really learn it, even if it seems weird at first. Learning Haskell is much like learning to program for the first time. It's fun. That's what we want. We want fun. It forces you to think differently, which brings us to the next section. So, what's Haskell? Haskell is a purely functional programming language. In imperative languages, you get things done by giving the computer a sequence of tasks, and then it executes them. While executing them, it can change state. I guess I know where this conversation is going. Let's keep going. For instance, you set a variable a to 5 and then do some stuff, and then set it to something else. Okay, that's what I'm doing pretty much every day. You have control flow structures for doing some action several times. In purely functional programming, you don't tell the computer what to do as such, but rather you tell it what stuff is. The factorial of a number is the product of all the numbers from 1 to that number. The sum of a list of numbers is the first number plus the sum of all the other numbers, and so on. You express that in the form of functions. You also can't set a variable to something and then set it to something else later. If you say that a is 5, you can't say it's something else later, because you just said it was 5. I mean, I get that. Makes sense. What are you, some kind of liar? Yeah, that's what I was going to say. Like, so in purely functional languages, a function has no side effects. So a side effect is basically something happening outside of my function, like modifying some value somewhere else in the program, which in object-oriented programming, I mean, that's the core concept of it, working with side effects. Like you're calling a function, you're passing in some object, instance, and call a function on that, which will then modify an instance variable of that object, all while being in some other function. And that makes me really crazy because it's so hard to reason about it. The only thing a function can do is calculate something and return it as a result. It's pretty much like mathematics. At first, this seems kind of limiting, but it actually has some very nice consequences. If a function is called twice with the same parameters, it's guaranteed to return the same result. That's called referential transparency. And not only does it allow the compiler to reason about the program's behavior, but it also allows you to easily deduce and even prove that a function is correct and then build more complex function by gluing simple functions together. That sounds so awesome. Like, just reading this makes me feel delighted. Haskell is lazy. So am I. Did I just find the perfect language for me? That means that unless specifically told otherwise, Haskell won't execute functions and calculate things until it's really forced to show you a result. Reminds me working towards a deadline. That goes well with referential transparency, and it allows you to think of programs as a series of transformations on data. It also allows cool things such as infinite data structures. Say you have an immutable list of numbers xs, 1, 2, 3, 4, 5, 6, 7, 8, and a function double me, which multiplies every element by 2 and then returns a new list. If we wanted to multiply our list by 8 in an imperative language and did double me, double me, double me, it would pass through the list once and make a copy and then return it. Then it would pass through the list another 2 times and return the result. In a lazy language, calling double me on a list without forcing it to show you the result ends up in the program sort of telling you, yeah, I'll do it later. Whatever you say. But once you want to see the result, the first double me tells the second one it wants the result now. The second one says that the third one, and the third one reluctantly gives back a doubled 1, which is a 2. The second one receives that and gives back a 4 to the first one, right? Because it doubles the 2. The first one sees that and tells you the first element is 8. So it only does 1 pass through the list and only when you really need it. That way, when you want something from a lazy language, you can just take some initial data and efficiently transform and mend it. So we are just like building up functions, right? So I call double me on double me on double me, and like the first double me will not return me the value, but it will return me the function definition of the other 2 double me's. Is that correct? I guess. And then when I, for example, say I want the first element of that, let's say x equals this construct, then, only then, it will produce the output of it. That's kind of an interesting approach. So it will not go through the whole list. It will just apply the function on the amount of elements I'm looking for, which at first seems counterintuitive because you will wait longer for the result by default because it is not pre-calculated. But I can see the advantages if you're working on really big list structures and only need like a very small subset of it. Yeah, why not? I'm open to new stuff. Haskell is statically typed. When you compile your program, the compiler knows which piece of code is a number, which is a string, and so on. That means that a lot of possible errors are caught at compile time. If you try to add I just have to pause here. This is really something awesome. Also in Elm, like it is very, very unlikely to have any runtime exceptions or errors anymore. Right? These functional languages makes it so easy to reason about what is going on in your code that you won't have some ugly side effects, and all the debugging in general is much, much easier. If you try to add together a number and a string, the compiler will whine at you. Yeah, for real. That's a good thing. Haskell uses a very good type system that has type inference. That means that, yeah, I know what that means. We don't have to define the type because it can figure out that 5 plus 4 is a number. So you don't have to tell Haskell that A is a number. But I guess like in other languages, you still have to tell the compiler that it is actually not an integer but a float, or things like that, because it looks like an integer, right? Type inference also allows your code to be more general. If a function you make takes 2 parameters and adds them together, you don't explicitly state their type. The function will work on any 2 parameters that act like numbers. Oh. Let's read that again. Not sure if I got that part. If a function you make takes 2 parameters and adds them together, and you don't explicitly state the type, the function will work on any 2 parameters that act like numbers. Oh, this basically resolves like, oh, so they have a higher type for numbers. So integers and floats are both part of a common data type. Is that it? I guess that's what they're trying to explain. Jumala. Elm has great error messages too. Haskell less so. Yeah. I mean, Elm is like an enhanced version of Haskell, I would say. I was hoping for a very long time that they would extend that language to also compile to server-side or client-side binary code. But unfortunately, it was like it is a feature complete project now. I don't think anything will happen anymore in Elm, but everyone who creates a new language should definitely have a look at Elm first, because the compiler is basically like really your friend and not just throwing up at you. Yeah, you're right on this. You're so right, Jumala. Haskell is elegant and concise because it uses a lot of high-level concepts. Haskell programs are usually shorter than their imperative equivalents, and shorter programs are easier to maintain than longer ones and have fewer bugs. Yeah, kinda. Haskell was made by some really smart folk with PhDs. I don't really think that this should be the reason to use it, because I guess most people who create a language are really smart, with or without PhD, doesn't really matter. But it's nice pointing it out. Work on Haskell began in 1987. Oh boy, that's an old language. When a committee of researchers got together to design a kick-ass language. In 2003, the Haskell report was published, which defines a stable version of the language. Oh, it took them 6 years. That's fast, no? To create a language from scratch in 6 years and have a standard afterwards. Jumala, you'd think language creators are all super smart people with PhDs. I didn't say with PhDs. I said smart people, and it doesn't matter whether they have a PhD or not. But Kubiman is making a language too. Oh, Jumala is just trolling his friend here. I have HDHD instead, so it's okay. I mean, more letters are better, right? I'm also on the HDHD club. So maybe let's make a language together. One where we really can focus on, like a language where distractions are intentional. And if you are not distracted and do something else in your code, then you ain't gonna make it. That would be an awesome language. So what you need to dive in, a text editor and a Haskell compiler. You probably already have your favorite text editor installed. Nope, sorry. Brand new PC, nothing installed. So we won't waste time on that. Oh, you bet we will. Oh, you bet we will. For the purpose of this tutorial, we'll be using ghci, the most widely used Haskell compiler. Okay. The best way to get started is to download ghci, which is recommended Haskell installer. ghci can take a Haskell file. They usually have HS extension. Yeah, okay. It just compiles my stuff. And it also has an interactive mode. That's cool. Neat. You can call functions from files that you load, and the results are displayed immediately. For learning, it's a lot easier and faster than compiling every time you make a change. Then running the program from the prompt. But it still means I have to compile it. Like, it's not like some kind of hot reloading. We will see. I guess it's not. Not many languages have that, and I would be quite surprised if Haskell does, as a pretty old language out there. But who knows? The interactive mode is invoked by typing ghci at your prompt. If you have defined some functions in a file called, say, my function, you load up these functions by typing functions, and then you can play with them. Provided my functions hs is in the same folder. Yeah, okay, that's just some path problems. Oh, that's how we reload it. Okay. Okay. So it's not a hot reloading, but we have a shortcut to recompile the imported function. Yeah. Why not? The usual workflow for me is when playing around in stuff, is defining some functions, loading it up, messing around with them, and then changing the file, loading it up again, and so on. And this is also what we will be doing here. Awesome. Awesome. That was a great introduction. That was a great introduction. So let's finish up today by setting up the compiler. Let's see how it works. And maybe, like run one quick Haskell function just to see that it works. So that on day 2 we can actually learn something about the language. So, to install on Linux, macOS, FreeBSD, VSL2 support to run the following in the terminal. No, I think there are better ways to do it, right? Let's see, installation. Nix is the way. Yeah, maybe. If you show up like a few times here, maybe in 5 days, I will be on NixOS. And I will be pretty pissed because then OBS and nothing will work anymore. But hey, we're just here for having fun, right? Yeah, let's see. Let's not waste much time on this. Let's just copy this and switching to the terminal, where we, by the way, also need a better terminal, right? This is like KDE standard terminal. Nothing fancy, but might work. Distrobox create. I never know how this works, so Distrobox create. We choose some image. Piping curl to shell. I hate that pattern. Yeah. It's definitely. I don't know why it has become so mainstream, especially because we have so many package managers available anywhere. But for some reason, it seems to be the way to infect our computers. I mean, even the Nix installer is piping curl to shell. So, what are we going to take? Ubuntu. Maybe. And let's give it a name, like Haskell test. I think that's enough. Do you want to pull the image? Yep. All right, and now we enter our Distrobox. It will do like the basic OS setup, and then we can pretty much pollute the system as much as we want and piping everything we want into the shell and just tear it down once we're done. Like it never existed. We are in. So here we can do our crazy curl to shell. It will tell us what to do. Welcome to Haskell. The script, is it fine, or should I make it like increase the font size a little bit? Welcome to Haskell. The script can download and install the following binaries: ghcap, ghc, cable, whatever that is, stack, whatever that is, HLS, a language server for oh, that's the Haskell language server. That one we are going to need. Press enter to proceed or Ctrl-C to abort. Note, this script can be rerun at any given time. Is it an info or a warning? Let's go for it. Let's go for it. Oh, that's pretty big download. Oh no, it isn't. Just a pretty long ping to the location wherever it is hosted. So, system requirements. Please ensure the following distro packages are installed before continuing. You can exit and return anytime. Oh boy. Now NixOS becomes more and more an option. Update. Of course. Sudo and sudo apt install all the packages. Oh, I'm so glad we didn't do this on my host system. Is it Dutch? That really feels painful to install Haskell, to be honest. Like, is this how people install it? Like, I can't. It doesn't feel good at all. It doesn't feel good at all. Yup, everything is installed. Let's go for it. ghcap provides different binary distribution channels. These are collections of tools and may differ in purpose and philosophy. First, we select the base channel. Keep the current config. ghcap maintained, vanilla upstream maintained. So here we are. Another question where we don't have an answer to. Let's just go with, we are installing through ghcap. So let's just stick with that, or with the default. Detected bash shell on your system. Do you want ghcap to automatically add the required path variables to my bash rc? Yeah, go for it. Do you want to install a Haskell language server? For now, we won't do it because this whole system we will trash it afterwards. We will do the installation properly afterwards. Next time, tomorrow. Do you want to enable better integration of stack? I don't even know what this is. So for now, I guess we're just going with the default. And here we are downloading some stuff. So here we go. No, we don't, because we need to reload our env. But no, here we go. Hello, Haskell. Oh boy, that's a long help page. So we're in. We've done it. First day. We know what Haskell is approximately from the introduction. We have a running command line interface. So everything that is missing now is we want to run something in it. Let's just have a little sneak peek. Or we can actually run this, right? A equals 5 plus 4 and see what the output is. A equals 5 plus 4. That's nothing. Oh, it is that lazy? Is it that lazy that it is just stored in the variable now, but it's not computed? That was unexpected. Like every other interactive CLI tool would have printed the result or like something. It can't be more lazy than me. So how do I print this now? So what they said is I can't reassign it, right? So now if I say a equals 1 plus 2, no, it works. No error. So I can reassign it. You can do it without the assignment or just print A. Let's try this because I understand what it means. It is 3. What a liar. So I can override stuff. Oh, I thought I wasn't supposed to reassign values to variables. In ghci, you can reassign as much as you want. Oh, okay. So it's just like a playground. I see. But if I do it in code, then how do I leave? This is like being the first time in Vim. Control C doesn't let me out. How do I quit this? Here we go. Quit. Okay, let's give it a try. My func. That is sad. No Vim in a fresh Ubuntu installation. My func Haskell. Now here I can just write stuff down, right? So if I do 5 plus 4 and then a1 plus 3, or do I need to define a function? Because I don't know how to define a function. And now if I load this stuff in... Huh, okay. Multiple declarations of A. So that won't work. Great. Let's try Control D. Oh yeah, that's cool. That's cool. And what else did you say? Infinite list of all odd numbers. 1, 3. Oh, because it's a pattern. Do I need a comma here? This looks weird. It feels better with. Let's see. No, you didn't do a typo. Okay. My bad. My bad, just trying things out, you know. Getting used to the syntax, not knowing anything about that language. Oh. Interesting. And so how do I get the last element of this? There's not much difference between a function and a value in Haskell. You can think of a as a function that takes no parameters. Okay, get it. So we want the last element of that. There is no last element. Yeah, that's pretty much, yeah, that's what I meant. So I can only go through the list from the left to right, right? I can never go from right to left. And it is just like an infinite odd number provider. Yeah, makes sense. Okay, cool. Cool. That was quite a good first day, I would say. I had fun. I can say I had fun. Oh, I want to try this before stopping it for today. I want to try this hot reloading or reloading, simple reloading. It's not a hot reloading. I want a split view. Okay. No. Here we go. All right, and then here we do our my function, right? And here we will load it. Load my function. And now A should be like this list. Can I check the type somehow? A is an integer. No, that's wrong. It isn't, but fine. Oh no, it's a list, right? Is this a list? Yes, I guess. And now let's say it is just 1. And reload it. Compiling main. Yeah, okay, it's compiling. It's I've seen this type parameter while scrolling the help earlier. Okay. That's cool. That's cool. I like it. Great language. Great language. So that's it for today. I was supposed to do this alone. I wasn't expecting anyone to join, so thank you very much for being here and following along. It was a pleasure for me to do this together with you guys, and I hope you have a great day, and see you next time. Bye.